Hi, we are the Player Piano Team, a multidisciplinary senior design team at the Kate Gleason College of Engineering. Our goal was to design a player piano device that could accept MIDI files and had an accessible input method for people with reduced fine motor skills.
For this iteration of the player piano, there was a lot more focus on the accessibility aspect of the project. So when we were in the brainstorming phase, we really wanted to create something that meets these requirements. Through interviews with our customer, we were able to boil down the set of customer requirements given to us to a set of engineering requirements that we could test and measure against. From these requirements, we started to break down the functionality of the piano and came up with a design that could achieve these requirements. To meet the requirements of the customer, we broke the piano into 4 different modes: a standard piano, a player piano, an accessible input mode of the piano, and a combination of these modes.
The standard piano mode is very simple as is, just a piano. But to make this work, our player piano system would have to not interfere with the standard inputs of a piano. The system created sits inside the piano and strikes the hammer of a note directly by use of solenoids so that the keys of the piano are left untouched. The solenoids are mounted to an 80-20 rail by 3D printed brackets in a staggering arrangement that is wedged into the sides of the piano to keep it sturdy. The solenoids are mounted to be able to have adjustments to align them properly, as well as the 3D printed brackets that can be moved to refine the alignment even more.
The solenoids are controlled by a Raspberry Pi. This interfaces with a PWM controller and a custom PCB to activate the appropriate solenoids based on the incoming MIDI messages. This allows for dynamic volume control and the ability to trigger specific solenoids in real time. The MIDI messages are received through a USB adapter and are generated by an external application developed by the software engineering team.
For our accessibility mode, we have an array of 10 buttons separated into 2 different boxes. These boxes are then plugged into an accessible Xbox controller, as the signal sent out of the controller is consistent no matter what signal is received. This gives us the possibility of a variety of different inputs, like levers, buttons, pressure pads, etc., to be used and not change how the software handles the input. When the accessible inputs are being used, the MIDI stream that the Raspberry Pi receives is the same as in the player piano mode, and the same solenoid control is implemented.
Another cool aspect of the accessibility mode is if the MIDI file is pre-filtered, then a combination of player piano mode and standard inputs can be done at the same time. This means if you could only play with one hand, you could play half the notes while the piano plays the other. A harmonious duet between music and technology.
We would like to thank our client, Ron DeFort, for his time and resources, and our guide, Harold Paschal, for all his guidance throughout the entire course of the project. We would also like to thank everybody at the MSD office for all the support and help they provided.